In this video, we're going to talk about loops. Loops appear in almost every programming language, and even if you don't always see loops, they're usually being done behind the scenes. Loops are a way to get the computer to do something over and over and over again, and this is one of the big benefits of computers. So we're going to start with a short set of slides just to give you the basic idea, show you the syntax, and then we'll jump right into some programming examples. Let's talk about loops. So what is a loop? Well, you can think of it kind of as a roundabout. If you're familiar with this type of driving structure, you get into it, and you could, if you wanted to, just keep going around and around and around and around again. And this is because many times you want to do something over and over again in your program. Computers are great at this. You just tell them what to do, and they'll keep doing it. And what you'll find is if you don't tell them to stop, they'll keep going forever. And sometimes you'll want to do something 10 times, 100 times, 1,000 times, 1 billion times even. And again, if you know how to do this, the computer will just go for it for you. Sometimes you may not want to do something 1,000 times or 100 times. You want to do something until you decide, or maybe the computer decides to stop. So you may not know in advance how many times you want to do it, but there are different ways to approach this problem. The first one that I'll start off here with is a for loop. This is my favorite way to loop over things in Python. It's what I use most of in my code. So for instance, it's really useful if you know you want to do something 10 times. If you want to keep track of something that you've done, nothing happens automatically in your code. This is going to be a theme throughout the course. No programming language knows what you do until you tell it to. It can't read your mind. So the loop says that you're going to do something over and over and over again, but the loop is going to count how many times you've done it or where you are in the process. So think of it as like keeping a checklist. Your for loop is going to keep track of something, how many times it's done it. It will do the counting for you so long as you set it up right. And then if it wants to, it will break out of the loop. So let's see how we do this. The syntax that we'll use is for I in, and then you see this little square brackets things. We've got a list here of 1, 2, 3. And that says that do something for each element, for each entry. So you'll hear me use this word element, which is just an entry in the list. For each element, assign it to the value of I and then print it. So your output looks like this. So again, just to reference yourself, you're going to loop over the numbers in this list. Each time you go through the loop, you assign it to the variable. So the first time in your loop, you assign the value of 1 to I. You can print it out, and then you get the output 1. You then assign the value of 2 to I, print it, and then you assign the value of 3 to I, and you print it. So for each element, you do something. And notice I'm using 2 spaces here, this white space or tab, this indentation to say what is in the loop. And I could have a whole bunch of other stuff down here inside this loop. So long as it's indented, it will do it each time I go into that roundabout. Think about that traffic circle. I'm in the traffic circle, and once I'm not indented, then I'm out of the loop. There's also while loops. So these are useful if you want to do something until something happens. So that means you've got to keep track of that thing to see if it's happened yet. And again, this is never done automatically. So what you do is you set up your loop so that you go over the same thing many, many times, but you have to keep track of something. And that thing you're keeping track of is usually maybe some total variable, or maybe it's some other parameter, something that you're reading in from some sensor or something. The syntax here is you have to declare some counting variable first. In this case, it's I. So you set it I equal to 0. Notice this is not indented. And then you go into the loop and you say, look, I'm going to keep doing this while the value of I is less than 2. We've got this little colon here at the end, just like the for loop. And then we've got this indented region here where we print I, and then this part is very, very important. We add 1 to I. So the first time through the loop, I is 0, we print it. The next time through the loop, I is 1, we print it. And this loop is only happening while I is less than 2. So once I gets to be 2, it is no longer less than 2, and we break out of the loop. This is just, again, that what I just said. The first thing we do is we assign a value to this I'm going to call this the counter variable because it's counting how many times we go through this. We set up our requirement to stay in the loop, so while I is less than 2. And then we keep making the variable counter bigger. Otherwise, we're going to run into an infinite loop. And then we print it, and this would be the output that you see. So let's go ahead and get started with our Python notebook, and we'll try it out. So let's put this into action. So again, these loops tell us how to loop over something. That means we're going to tell it to do it over and over and over again. And we're going to talk about while loops and for loops. And I'm actually going to start with while loops. So a while loop tells the computer to keep doing something while some condition is met. So this could be something you've determined in advance, keep counting until you get to 100, or maybe the computer needs to determine when to break out. So you might have your computer hooked up to some sensor, and when you get a non-zero reading, then you break your while loop. And we'll show that you can use the break statement for that. We're going to emphasize why these loops are helpful by just doing some very simple basic statements. So let's try to do something without them first using a print statement. So let's suppose I wanted to print 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And all I could do was actually print out each statement. So I'm going to print 0. Then I'm going to print 1. Then I'm going to print 2. Then I'm going to print 3. Then I'm going to print 4, and then you know what comes next. I'm going to print 5, and then I'm going to print 6, and then I'm going to print 7, and then, oops, messed that up, print 8. Getting tired of this, and then I'm going to print 9. And now when I run this, it'll just print one after the other. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now that was kind of frustrating and a little bit annoying. So let's see if there's an easier way to do this with our while loop. Okay, so the first thing I would do is I would set up a variable. This is going to be my counter variable. Let's call it I. That's a classic. We'll set it equal to 0. I'm going to tell this to keep printing it while it is less than 10. So I'll do while I is less than 10. And notice there's a colon here. And once I type that colon, the Jupyter Notebook automatically indents me 2 spaces. So that's great. So now I'm going to print I. And if I were to just run this, I'd have an infinite loop because I would never change. And so what I'm going to do down here is I'm going to make sure everything is tabbed in. And I'm going to do I plus equals 1. And if I run this, I see, oh, some stuff happened here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we set a variable I equal to 0. We went into our while loop. We said, keep doing this while I is less than 10. We print it in the loop. This is all indented, so it happens inside the loop. I is equal to plus 1. And if I wanted to, I could, outside of the loop, just to show you that I'm done, I could type the end. And so that happens outside of the loop here. It's only prints once. If I did this inside the loop, if I indent this and I run this, each time it prints the number, it also prints the end. This is a classic mistake that I've made many times. By de-indenting it, it knows that it is no longer in the loop. I run this, it just runs the up to 9, the 10 times, and then prints the end. Now I'm going to show you what happens if you accidentally create an infinite loop. So let me put a little comment here and hashtag. Now it is not going to change I. So I is 0. And then you do I less than 10, print I, but I is always 0. So it keeps going and going. So let's create an infinite loop. I'm going to run this. And you can see I'm just printing zeros and zeros and zeros. This is just spinning and spinning. It's not going to break out of it. You can stop it here by pressing the little stop button, or you can go to runtime and do interrupt execution. Might not have clicked on it. Okay, there we go. And once it breaks, then I get this error at the bottom here. That's okay. I'm just going to go back and uncomment this I plus equals 1 and run it again, and everything is fine. Okay. And just to remind you, we made use of the plus equals operator. So it takes the value of something, increases it by some amount. In this case, it increases it by 1 if I do x plus equals 1. And that's equivalent to say that x is equal to the old value of x plus 1. Now, how could we use this while loop? Let's show an example. Let's suppose I wanted to add up all the numbers between 1 and 100. Now, you should always know how you would do something without your programming code. So if I gave you pen and paper and I asked you to add up all the numbers between 1 and 100, you should be able to do it. And the total is going to equal 1 plus 2 plus 3 plus 4 plus 5, and so on. Now, that's hard to keep track of. So if it was me, I would probably break it up. I would do 1 plus 2 equals 3, and I would call this my new total. On the next line, I would take 3, and I would say, well, that's really my old total now. And I would add 3 to it, and now I get 6. And now that's my new total. My old total, which was 6. Now on the next line, I add 4. So I'm adding 2, 3, 4, and so on. So I've got this total that I keep changing. Now, how would I do this in a while loop? Well, why don't I just create a variable called total? You're not always going to need this. And I've noticed some students sometimes think that you always need something called total. You don't. This is just because we're actually summing up all of these different numbers. So I'm going to declare your counter. I'm going to use I here for I equals 1. And then I'm going to go into the loop. So while I is less than, and what did I say? I want to add up to 100. So it says between 1 and 100. But maybe we want to actually keep 100 in the list. So we actually want to include 100. So let's say while I is less than 101, and then I'm going to do total plus equals I. So each time through the loop, total gets I added to it, which starts off as 1. Then it's going to be 2, then it's going to be 3, and I keep adding. And of course, I better make sure that I add 1 to I, otherwise I'm going to be in a infinite loop. And if I print out the total at the end, I get 5,050. Now, if I was debugging this and something was going wrong, I might do something like, well, let me print total and I. Let me just see what's actually happening here. And if I do that, oops, I made a mistake here. Total equals I. If I do that, so I put this print statement here. You'll notice I've got to pull this down here, bring this little slider up to the top. So total is 1. I've added 1 to it. Then the total is 3. I add 2 to it. Total is 6. I add 3 to it. Total is 10. I add 4. Total is 15. I add 5. Total is 21, blah, blah, blah. I keep adding the number that I did add to it. So again, this is the number that I added to get my total, and it keeps going up and up, and then we get all the way, scroll down to that final print statement of 5,050. I'm going to comment out that print statement here just in case I come back to this or I need to do anything, run it again, and I just get the total is 5,050. Now let me introduce you to one of the most challenging things about loops, and this is the idea of nested loops. So these are loops within loops. It's very tough, but it is worth learning because you'll find that you need it sometimes. And I guarantee you the hardest part of this is keeping track of the indents because every time you have a new indent, you're going into a new loop. So let's declare a variable for the counter for the outer loop. I'll call this I. This is going to be 0. And now we're going to go into the outer loop. So let's say while I is less than 5, let's say. And I'm going to print the outer counter here. I'm all indented. So print I, and I'm going to give it a little bit nicer print statement. So this is the value of I. I'm going to now declare, while I'm inside the loop, I'm going to declare a variable for the counter for the inner loop. So let's call this right here the outer loop, and then I'm going to an inner loop. And I'll say that j, don't use I again because I already used I up here, j is equal to 0. And now I'll go into the inner loop here. And here I'll just count while j is less than 3. Don't forget your colon at the end of that. I'll print the inner counter, and because I'm trying to make a point, I'm going to print it again with an F string, but I'm going to do a tab. So the /t just tabs everything in. You'll see why this is in just a moment. And then I'll just make sure that I know that this is the value of j. Inside here, we better make sure we increment our inner counter. So j is plus equal 1. And then I will increment the, oops, I went too fast. I will increment the outer counter, which is I, plus equals 1. And then I'll just make a little print statement at the end. I'll just say out of the loop. Yay, we got out. So I declare a variable for the outer loop. While that variable is less than 5, I'm going to keep looping. I'll print it just so we can see what it is. Then I'm going to declare a variable for this inner loop. For counting, I'll use j. I don't want to use I again. And while that value is less than 3, I will print it. And each time I go into another loop of this outer loop, j gets reset. And then I increment the inner counter. I increment the outer counter. And so look at this. I is 0. J goes 0, 1, 2. Then I is 1. J gets reset. 0, 1, 2. I is 2, and so on. And then we're out of the loop. And you will find yourself using this at some point. So I encourage you to take some time with this syntax and all of how we did these indents to make sure that we're in one loop and then we go into another. Okay. So let's use this loop to print the sum of even numbers between 1 and 100 inclusive. Inclusive means that we're going to include 100. So how would we do the sum of even numbers with a while loop? So I would have my little total that's equal to 0. I would set my counter. I would say that I equals 0. That's my counter. And then I would say while I is less than 101, because we want to include 100, total plus equals I. And then I'm going to do I plus equals 2 because we only want the even numbers. Now, am I doing this right? Why don't I go ahead and I will print up here, print I, and then total. So ideally, I will start at 0, and then it'll go 2, 3, 4, 5, and so on. Or sorry, 2, 3, 4, 5. It'll go 2, 4, 6, 8, 10, 12, and so on. I don't know why I did it not even. So each time through, we add 2 to it. Here's the total. The total keeps getting bigger and bigger. And now I'm just going to comment out my print statement. And here I'll print the total. I get a 2550. Which is about half of what we had before, except we actually get the 100 at the end instead of just if we were to do odd numbers. Okay, let's get into for loops because I use these all the time. While loops definitely have their place, but I find myself mostly using for loops. This is good if you know how many entries you're going to loop over, or you have some list or something where it's already defined, maybe a data set, and you know you're going to loop over all the entries. And we'll do this a lot in the class. So in the example below, I'm going to have you create a list. We're going to call it my list, and we're going to call it we're going to fill it with the words room 1,000 years wide. For those of you who aren't familiar with it, this is a classic, amazing, powerful Soundgarden song. I encourage you to go look it up. But we're going to loop over it to print out each individual word. So I'm just going to copy this right here. I can copy that down here because I gave you the syntax, then I don't have to worry about accidentally mistyping something. So I've got my list is equal to room, comma, a, comma, 1,000, comma, years, comma, wide. And now I'm going to loop over this. I'm going to assign each value within the list to an x variable. But of course, I could call it whatever I want. And all I have to do is for x in my list. So for each variable that is in my list, I'm going to assign it to x inside the list. And I'll just go from one to the other. And I can print x. So the syntax is actually maybe not much, but it's simpler than the while loop because I already know all the elements that I'm going to loop over. I, of course, don't have to call it X here. I'm just assigning it to these different variables. I could call it lyric for lyric in my list, and it'll each time through the loop print out the value of lyric. The value of lyric has been assigned from each entry in my list. And I like this idea of using variable names to represent what they hold. So imagine that I asked you to declare this list and then print it using good variable names. So I'm going to cut and paste this down here, and I'll call this teams. Instead of my list, I'll call this teams. For those of you who aren't familiar, those are teams in the AFC East. And then I could do for team in teams. So the singular of team in the plural of teams. There's my list. And then I can print them. I can use an F string. I could put the and then team are a team in the AFC East. And then I just do that. The Dolphins, the Bills, the Jets, the Patriots, and so on. So again, I declared my list here, teams, and then I'm using, I'm just writing it in a way that I feel like it's a little bit easier to understand. But each time in the list, this gets printed out. And of course, I don't have to call it team. I'm going to do it. I'm just going to copy that over again. Make sure I get my indents right. Little space here. And I could just call this for X if I wanted to. For X in teams. And I print it again. I get the same thing because in my loop, this variable is what I'm printing down here. Now we'll use the range function a lot. When we did our lecture on lists, we saw how we could change range into a list, but we actually don't have to use it here. I have to change it into a list here. We can just use it with a for loop. So you'll see me do something like if I want to print the numbers from 0 to 9, I'll do for I in, that's my variable. And then I'll use range and I'll do 9. And then I'll print I, making sure that this is indented and making sure I have a colon at the end. And if I print that, if I run that cell, I get 0, 1, 2, 3, 4, 5, 6, 7, 8. I wanted 0 to 9, so this should be 10. So it stops just before the 10. And I run it and I get 0 up to 9. I didn't have to declare any, I equals 0 at the beginning because range starts at 0 already. And if I wanted to print the numbers from 4 to 9, because we went through the range function in the lecture on lists, we can do for I in range, and then we start at 4, comma 10, and so this will stop just before 10. Print I, 4, 5, 6, 7, 8, 9. If we wanted to print the numbers from 3 to 33, right now I'm just doing a review of range. We could do for I in range 3. We want to get 33, so let's stop at just before 34. And we want to go in steps of 3. So I put a little 3 here. And that means I'm going in steps of 3. And then when I print I, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and 33. So when we have entries in a list, we can either loop over that list directly, or we can use the range function to generate the indices, the index for each entry in that list. And this is something you may want to do if you want to actually grab those words, let's say, or those numbers and do some calculation. So what we're going to do is we're going to take the words that are the beginning of the litany against fear. This is from Dune. The words are, I must not fear, fear is the mind killer, and it goes on and on. We're going to use a for loop to loop over it directly, like we just did. And then we're going to use the range function to get each word using an index. So the first thing I'm going to do is I'm going to declare my list just by cutting and pasting. I've done some of the work for you. And if I do for word in words, and then I print word, again, colon here at the end, indent there, I'll get, I must not fear, fear is the mind killer. The other way you could do this, I've already got words declared, so I don't have to do this again, is I'm going to generate the indices using the range function. And while this may seem like a little bit of overkill, it turns out to be very useful sometimes when you actually want to get the word or the numbers in some analysis and do something with it in your calculations, as well as keeping track of where you are. So let's get the number of words. Get the number of words. We're going to use that len function. So n words equals len words. This is something we did when we did our lecture on lists. And then what I'll do is for I in range n words. And if I was to just print I would get, well, I would get 0, 1, 2, 3, 4, 5, 6, 7, 8, because there are 9 words. Well, that's not that interesting. So I'm going to comment that out. And then inside the loop, because I'm all inside the loop, I'm going to have a variable. I'm going to assign to it words I. And now if I print I, comma, word, what I should get is the index and then the word itself. So 0, I, must, 1. That is the index of each one. And then I could do something words if I wanted, but I could use this if I wanted to do, let's say, use an F string, and I could say word is at index, and then I could do I here, and then this would be a little bit more information about where they are in the list. And there are even ways to shorten this if you wanted to, but this is a little bit more explicit way of showing you how to print this stuff. So suppose I wanted to use a for loop to add up all the even numbers from 1 to 100. Well, I'd have my total, that equals 0. Then I have my for loop for I in range. I'll start at 0. I'll go up to 100, but I'll actually go to 101 because I'll stop just before that. That's how the range function works. And I want to go in steps of 2. So let me just check myself if that's the right way to do it. I'll print I. Yep, looks like 0, 2, 4, 6, 8, and so on. I'll comment that out. I think this is useful for you to see how I often do stuff in just like one line at a time, just to make sure I don't have any mistakes. And then I'll do total plus equals I. Oops, almost mistyped that. Mistyped it. Total plus equals I. And if I print total again at the end outside of the loop where I am no longer indented, I get 2550, just like when I did that with a while loop. We will be doing many more examples with for and while loops really for the rest of the semester. We find ourselves using this all the time. Okay, hope this video was helpful. Reach out to me if you have any questions. Thanks for watching.